All right, so what we have here is the scatter plot with regression line for Obama vote versus insured, and we're going to define a residual. A residual is something that exists for each point, and it is the signed distance, the signed vertical distance from that point to the graph. So this here would be a positive residual. Whereas down here, if we look at this point, we can see it's below the graph, and therefore it has a negative residual. Looking at this, we can see the largest and smallest, or the largest positive and the largest negative residuals. I would say that the largest negative residual is pretty clearly down here at this point. And it's not as clear which is the largest positive residual. So we have a few contenders up here. This one is pretty far vertically from the line. These points here are pretty comparable, but I would say it's probably going to be one of those. I think maybe either this point or this point. So we're going to select a few of these and actually calculate their residuals. Let's go ahead and take this one, assuming that it really is the largest, even though we can see that it's possible that one of these others is as large or larger. So to do this, we're going to want a better estimate of these values than we can get from just looking at this picture. We're going to open this up in StatKey. Since we've already opened up this exact graph, all I need to do is show the regression line to see the version of it we were just looking at, and come up here and hover over the point to get the x and y coordinates. So this one is at 90, 0.7, and this one down here is at 80.8, 0.25. I'm going to go ahead and write those two values down. And we've already found this regression equation as well, using the slope of 0.009 and the y-intercept of negative 0.239. So putting all of this together gives us enough information to calculate these residuals. For the largest positive, our actual y value is 0.7, but our y hat, which is what we get on the line, we get from the equation using 90 for our x. So y hat is negative 0.239 plus 0.009 times that x value we found of 90. So bringing in a calculator for this gives us 0.239, which I'll make negative, plus 0.009 times 90. And that is 0.571. The residual is the vertical distance to the line, but it's a signed distance, so it's the actual y value minus the y hat estimate that we get from the graph. So we always subtract in this order. It's always actual minus estimate from the graph. From the regression equation. So that's going to be 0.7 minus 0.571, which turns out to be 0.129. For our negative residual, we'll do the same thing. So that negative residual had a y value of 0.25, but a y hat, which we will get from plugging in this x value to the regression equation. So my y hat is negative 0.239 plus 0.009 times 80.8. Again, we can bring in the calculator for to get 0.4882. My residual, again, is going to be y minus y hat. Which is the actual observed y value of 0.25 minus the estimated from the regression equation value of 0.4882, and we get negative 0.2382 for that residual. So we don't have to know going into it that the residual is going to be negative or positive. We always subtract in this order the observed value minus the y hat coming from the regression equation, and it should just work out to be positive or negative according to which one is bigger. Part of the point of residuals is that they help us define what is the best fit. We've been kind of glossing over that and looking at a scatter plot and just drawing a line that seems to describe the shape. But in fact, best fit takes all of these residuals. So it calculates residuals for every single point. We can see these ones are very small, but these ones are much bigger. So we calculate residuals for each point, and each one of those residuals gets squared. And we take the sum of the squares of the residuals. So, for example, our 0.129 would get squared. Our negative 0.2382 would get squared, etc. We would have a term for each point. And the best fit line, which is also the regression line, is the line that's going to give us the smallest possible value for the sum of the squares of the residual. That's what it means to say it minimizes this. So if changing the line could give us a smaller value for the sum of the squared residuals, then we would change the line, right? It sounds at first like a very hard thing to actually find, but it turns out there are some really simple formulas that give the best fit line that happen to satisfy this requirement. So it's not the case that a computer has to change the line and do these calculations over and over and over again in order to find this.